The modern game controller must accommodate for a wide range of programs, which means it requires great versatility and forethought. The evolution of the gaming landscape, from consoles to computers and now virtual reality, has pressured the industry to advance at great rates, all the way from large handheld controllers to slim VR controllers with motion tracking. With that being said, modern controllers still haven't been perfected to the point of full immersion within this new landscape. This presentation will attempt to identify current limitations of controllers and, in the process, create a controller that may highlight some overall improvements. Controllers are the mold through which users can interact with the virtual world. Industry standards that are generally observed to compare these controllers include tracking precision, build quality, ergonomics, battery life, and degree of movement. While motion control has been advancing, it is important to still provide other input mechanisms for user versatility. Alternative mechanisms include adaptive triggers, flight sticks, joysticks, and push buttons. Minimalist designs are common amongst modern VR controllers, putting focus on weight and balancing input methods. However, the ultimate goal for maximum VR immersion is for users to control the VR environment with their bare hands. This endeavor may involve the use of advanced gloves or even devices inserted into the human body. The realistically affordable option will still be handheld controllers for the foreseeable future. Previous research has highlighted that small handheld controllers work best within VR, largely due to the freedom of movement that they provide. Degree of movement will receive the most focus for this new design, as this feature strongly affects user immersion. Input buttons will also be added for necessary game features. Arduino products will be used to create the controller's button features and program their inputs, while Unity software will be used to translate that technology into a digital game format. Before development could begin on the controller shell, the internal parts had to be completed. Firstly, I had decided to use two buttons as the input mechanism for simplicity. These buttons were connected to a breadboard and wired accordingly to the Arduino Uno. After uploading a simple button pressing code to the Arduino Uno and testing for problems, I created a Unity project and connected it to the Arduino device via its port. This process proved more complicated than I had originally expected. However, in the end, everything worked. After the inner parts had been completed, I began creating the shell. The shell attaches to the user's palm via an elastic strap to provide maximum movability, with an angled thumb rest, as well as two cutouts for the buttons to be used from. The result is a dual-wielded controller that attaches to the user's palm and provides great degree of movement, since users needn't worry about dropping the device. The elastic is adjustable to the user's hand size and provides strong support. Unfortunately, the inner components proved larger than I had expected. This led to an increase in the shell's size, which does impact the user's comfort and is noticeably heavier. The dual buttons work well for simplistic games, however, another mechanism such as a joystick would be an improvement. The most significant important feature of this design is the degree of movement that it provides. Though not perfect, I do think this controller has highlighted an improvement that could be applicable to many modern controllers. The experiments conducted in this article have been largely successful. Moving forward, VR controllers will continue to decrease in size to improve their degree of movement and move closer towards seamless interaction within the virtual space.